Okay, what we're looking at now is how to find the definite integral. So up until now, anytime we've anti-differentiated or integrated, we've always had a plus c because of the constant at the end. The thing that we don't know, if we've differentiated to get to something, then we've got something else. We don't know what it is. So what we're going to do now is we're going to get rid of that plus c, and we do that by anti-differentiating over two limits. So what we've got here, we've got 3x squared minus 2x plus 3, and we're anti-differentiating between 3 and 0. This isn't a 6, just looks like a 6, but it's actually a 0. So what we had to do when we anti-differentiate this, and we're going to do the same thing over here with sine of x over 3. So to do this, what we're going to do is we'd anti-differentiate these things, so it becomes 3x cubed over 3 plus 2x squared over 2 plus 3x, and we put it in square brackets. So we don't put our c, and then we put in our 3 and our 0. So that tells us we're going to substitute 3 and 0 into this equation here. So firstly, let's cancel some stuff. So 3 and 3 will cancel, 2 and 2 will cancel, so we're left with talking about cancelling. So we've got x cubed plus x squared plus 3x, and that's between 3 and 0. So what we do next is, then we substitute these values. So we'll have 3 cubed plus 3 squared plus 3 times 3. And we're going to subtract, and we're going to substitute 0 into there. So we'll have 0 cubed plus 0 squared plus 3 times 0. That's a 3. Let's fix that up. Okay, now we know we've got 0 cubed, 0 and 0. We're going to be left with minus 0. So here, 3 cubed is 27 plus 3 squared, which is 9. And I've made a mistake. We've got to subtract here. So takeaway, this should be a takeaway, that should be a takeaway, this should be a takeaway. So I'll fix that up. So this is minus, this one is minus, means this is minus, and finally this thing is minus. So then we've got our plus 9. So here we end up with just 27 minus 9 plus 9, minus 0, we end up with 27 square units. Okay, now we're going to have a look at this other one. So we're differentiating sine of x on 3. So I'll rewrite this as 4 pi. And we always put our larger limit at the top, 2 pi. And I'm going to write this as sine of 1 over 3 x dx, just because it makes it easy to work with. So now sine becomes negative cos, and if we've got negative, whatever our coefficient of x is, we take the reciprocal of that. So we end up with negative 3 cos of 1 over 3x. Oops, let's go here. And we're going to differentiate that between 4 pi and 2 pi. So from there, this now becomes negative 3 cos of 4 pi over 3 minus 3, that's negative 3 cos 2 pi over 3. So remember, it's always minus between two square brackets. So we'll substitute 4 pi and 2 pi, and it's always minus between them. So from there we go off and we do our calculations. So if we've got cos of 4 pi on 3, that gives us negative 1 on 2. So we've got negative 3, negative 1 over 2, minus negative 3, and 2 pi over 3 is also negative 1 over 2. So then we multiply, so 3 times negative 1 over 2, we get 3 over 2 minus 3 over 2. And we're left with 0. So that's what we've got there. So we're looking at some definite integrals. So we put our upper and our lower limits, upper and lower, and to differentiate with respect to x. And when we've done that, we don't put in a plus c, we put square brackets and we put our limits there. So once we've differentiated, square brackets, upper and lower limit. And then we take our upper and lower limit and we substitute them into this equation. And we subtract the difference. And that's how we go about finding a definite integral.